Assalamualaikum, and today my team will present hazard identification, risk assessment and risk control hierarchy at Chemistry Laboratory 2. This is my team member Abdul Hakim bin Ismail, Muhammad Afif bin Azharin, Nur Laili binti Muhammad Nur, Radatul Husna binti Muhammad Nizar and Siti Nur Jazilah binti Muhammad Sukri. All of us from RAS 2015A. Okay, next, the objective of this assignment is to find hazard in Chemistry Laboratory 2. By identifying the hazard, we can understand the potential and current risks involved. The assignment also aims to determine the existing risk control and suggest measures to mitigate the risk. The goal is to develop a proper hazard identification, risk assessment and risk control hierarchy process and create a standard operating procedure SOP for the evaluated laboratory. Okay, next, a hierarchy standard for hazard identification and risk assessment. It's basically a process used to spot and analyze hazard at a work site or a laboratory and figure out how to control or eliminate them. It's important because it helps identify potential dangers that could harm employees and others. By carefully implementing hierarchy, we can minimize or even prevent accidents from happening. It takes into account the likelihood to harms occurring in a specific situation and how severe the consequences could be. So it's crucial for ensuring safety and avoiding risk. So now we are going to the table 1 that contains list of activity that we observe in the lab. In this slide, we can see the preparation of NaOH solution, and the hazard that we can find is a chemical splash and chemical spill. It also contains risk, existing control risk and recommended control risk. It can be referred through the slides. In this slide, another hazard is a poor maintenance of fuel hood. The second activity is storing the lab apparatus that produce inappropriate place hazard. Next, another hazard for this activity is a dirty table that can cause contamination. The third activity is storing the chemical substance. The hazard we can observe is unseparated cabinet that mix up normal chemical and hazardous chemical. The fourth activity is a process of chemical waste disposal. The hazard is inorganized arrangement of waste container. The last activity we observe is malleability of metal sample using furnace. The hazard is inappropriate glove. In this slide, we will discuss about table 2, which is probability value based on identified hazard. For inappropriate glove, the rating is a 2, which is a reboot likelihood. For the chemical splash and chemical spill of NaOH solution, the rating is a 3, which is a conceivable likelihood. Next, the whole hazard in this slide is a rating 4, which is a possible likelihood. The hazard is a dirty table that used for storing the apparatus, unseparated cabinet that mix up normal chemical with hazardous chemical, a poor maintenance of fume hood, and an inorganized arrangement of waste container. Okay, next, in this slides, the last hazard we identify is inappropriate place, such as on table and near the sink. The rating is a 4, which is a possible likelihood. The highest value based on all hazard we identify is a 4.
My name is Abdul Hakim bin Ismail. Now, I want to highlight two critical aspects, the severity and consequences of different scenarios. Understanding both is important for the safety and well-being of our communities and workplace. In terms of severity, we categorize events into 5 levels: negligible, minor, major, fatal, and catastrophic. The major events bring noticeable harm. Fatal incidents result in significant harm to a large number of people, while catastrophic scenarios have severe and lasting effects. Regarding hazards and risks, let's focus on a few examples. First, during the preparation of sodium hydroxide solution, we must be cautious of chemical splash. Wearing goggles and appropriate gloves can significantly reduce this risk. Proper maintenance of fume hoods and storing the lab apparatus in designated cabinets are necessary to prevent toxic environments, equipment damage, and contamination. Storing hazardous chemicals separately is crucial to avoid misuse, while organizing waste containers properly minimize the risk of spills during disposal. When working with furnace, wearing heat-resistant gloves and full personal protective equipment is essential to prevent skin burns.
Risk matrix table is a tool used for assessing and visualizing operational risk situations and is the result of risk analysis and risk assessment. A risk matrix is used to rank risks according to their likelihood of happening and their potential impact or severity. It is displayed as a table with a range of likelihood and severity ratings that reflect various risk levels. According to our observation and analysis, The likelihood and severity only reach the level 4, which is possible and fatal respectively. The table must be tallied for both likelihood value and severity value. The severity of damage is noted ascending on the y-axis and the likelihood of occurrence noted descending on the x-axis. The maximum risk results from the combination of a very high likelihood of occurrence and a very high severity of damage. After identifying and defining both areas, we get a measured value, also called a risk value or risk indicator. Our group used traffic light color for the color coding system. This is done to show how dangerous a possible incident can become, as it can be used to identify critical areas and derive suitable measures. For the risk value, 16 is considered as high risk, 6 to 12 is medium risk, and 1 to 4 is low risk. High risk with a red color indicate a hazardous condition may cause frequent accidents, which may result in equipment losses, injury, or death. Medium risk with yellow color indicate an event resulting in risk that can cause an impact but not a serious one. While low risk hazardous with green color indicate condition that is unlikely to cause accidents, and if it does, result is only negligible damage.
Assalamualaikum. Now I will explain about table 6, which is a hierarchy table. The hierarchy table is used to determine and evaluate both existing and potential hazards on a work site. Based on work activity that happened in the laboratory that we observe, we can identify several hazards and recommend some control measures to avoid further accident from harming the workers themselves. Firstly, for preparation of sodium hydroxide solution, the workers should always wear a goggle and wear full appropriate PPE to avoid chemical splash and spill that will cause eye and skin irritation. The likelihood for this activity is considerable, while the severity is major and minor, and the risk is medium. Other than that, the workers should also follow the service manual for field mode to make sure it is safe to use by others and to avoid spread of toxins to the environment. The likelihood for this activity is possible, while the severity is better and the risk is high. For storing the lab apparatus, the workers should store the lab apparatus in a specific cabinet and not mix them up in the same cabinet instead of putting them at inappropriate places such as on table and sink to avoid broken laboratory equipment. The likelihood for this activity is possible, while the severity is negligible and the risk is low. Furthermore, to store the lab apparatus, the workers should store the lab apparatus in the clean cabinet to avoid contamination of laboratory equipment. The likelihood for this activity is possible, while the severity is minor and the risk is medium. Next, for storing the chemical substance, the workers should store the hazardous chemicals separately from normal chemicals, because when these incompatible chemicals mix, they may explode or release toxic chemicals to the surrounding. Other than that, the misuse of chemical substance can also occur. The likelihood for this activity is possible, while the severity is fatal and the risk is high. Moreover, in the case of processing chemical waste disposal, the workers should organize the waste container properly to avoid spilling of the waste solution. The likelihood for this activity is possible, while the severity is minor and the risk is medium. Lastly, the malleability of metal samples using a furnace should be conducted by wearing a heat-resistant glove and full PPE to avoid skimming. The likelihood for this activity is remote, while the severity is major and the risk is medium. To conclude, when accidents always happen, the severity is high because we put a lot of precautions to avoid it from happening in the future.
Now, I want to draw your attention to the hazards and risks associated with our work activities. During the preparation of sodium hydroxide solution, the hazards of chemical splash pose high risk. With the potential for severe harm, it is crucial to implement proper precautions to mitigate this risk. Another important consideration is the maintenance of fume hoods. Poor maintenance carries a moderate risk of potential harm to those working with toxic substances, so that regular servicing is essential to ensure a safe working environment. When it comes to storing lab apparatus, placing them in inappropriate locations or on dirty tables carries low risk. It's still important to store them properly and maintain cleanliness to minimize any potential harm. Furthermore, storing chemical substances in unseparated cabinet poses a moderate risk. It is essential to separate and store hazardous chemicals appropriately to prevent accidents and misuse. So, the proper organization of waste containers during chemical waste disposal is vital to minimize risk. Lastly, when working with furnaces, during the malleability of metal samples, using inappropriate gloves poses a moderate risk. It is crucial to use suitable gloves to prevent potential harm.
Next, we proceed to Standard Operating Procedure (SOP). SOP are the set of guidelines that specify how to carry out an activity systematically and effectively. SOP are commonly used in areas like healthcare, manufacturing, and food services to maintain quality control and safety. SOP can help to eliminate mistakes, boost productivity, and shorten new hire training periods. For the preparation of sodium hydroxide solution, the SOPs are we must always use safety goggles and gloves when working with the chemical. If there is chemical on your skin from a spill or splash, rinse it off right away with plenty of water. Before using the fume hood, make sure the certification sticker has a date within the last year. And finally, wearing appropriate PPE and avoiding certain kind of chemical and procedure that may be potentially hazardous. SOP for storing the lab apparatus is by labeling and keeping the lab equipment in a specific, clean, dry, and safe place. Moreover, SOP for storing the chemical substance are storing the chemicals in a dedicated area that is safe, well ventilated, and far away from items that might interfere the lab work. Next, labeling the containers with the name of the chemical, the date of the receipt, and any hazard warning or precautions. For the process of chemical waste disposal, the SOP are classifying chemical waste containers according to the hazard, which is flammable, corrosive, or toxic, and routine checks for spill, leaks, and other dangers in the storage space. And finally, the SOP for malleability of metal sample using furnace is by using complete PPE while loading and unloading the sample from the furnace, including heat-resistant gloves.